Imagine unlocking every secret movement on the pitch, knowing exactly where the game is won or lost. That's the power of real-time player tracking in Heatmaps. Right now, leading sports betting companies rely on this data to set sharper odds, power live bet markets, and monitor key performance indicators. Things like total distance covered, high-intensity zone, and dominant possession zones. But it's not just about numbers. These insights turn into real profit. By knowing which areas of the field see the most action, betting firms minimize risk, increase wager volume, and deliver faster updates to eager fans. In today's tutorial, you'll learn how to build your own computer vision tracking system from scratch. You'll capture player positions live, and also generate heat maps of high-intensity zone on ground.
Hello everyone, welcome to this tutorial on fine-tuning YOLO for football player tracking and player heat map generation. In this tutorial, you will learn how to track players in real time and even generate a player heat map which tell us about where the player has spent most of their time on the field. To, to do this, you have to just follow few steps. So first step, you have to create a data set. You can use live football matches footage for your dataset, and then you have to annotate those images on the classes you want to detect. Like here I am using 5 classes: team A, team B, ball, referee, and goalkeeper. Then you have to select each one by one and annotate the. After the annotation is completed, you just have to keep repeating this process till every images of your dataset has been annotated uh, perfectly. Then you can export the annotation in JSON format using labeler platform. Let's get to our next step. In the next part of our process, you just have to convert your COCO JSON annotation in YOLO format. To do this, you have to clone this repo, which I have already cloned. As you can see this, using this repo you can easily convert your COCO JSON to YOLO format, just providing your annotation JSON form part, your dataset part, and the output directory part you want to store your YOLO format. Then let's get to our next step. For our next step, you have to train the YOLO model. To train the YOLO model, you have to first import Ultralytics. Then from Ultralytics import YOLO and even import OpenCV and Matplotlib. Then you have to provide the your YOLO format, this file location dataset.yml to this command line. This command line will train your dataset for around 200 epochs. So do this. I just provide the dataset part to this variable dataset part, and that dataset part is with dataset.yml part is provided to data equals to. Using this, you can train your YOLO model. I have already trained my YOLO model. It took me around 2 hours to complete, and it stored my model in run folder. So let's get to our next step. So our next step is tracking player on the field. So to track player on the field, first we have to load our custom model which we have trained on our custom data set. So this is the location of our custom model called last.pt to the model. So let's run this. Now let's see our tracking on a specific frame. I'm using an example 30th frame to check how our tracking perform. It's simple to do. You just have to provide the result model dot track and the source of the video, and then process equals to and stream equals to, and that results give us these value boxes, track ID and class IDs. So let's get to our result. As you can see, these are the tracking happening. So this is the result it's showing. You can see we are getting a clear tracking. So let's see this in on a video. I'm providing a sample video. Our tracking is happening right now. As you see, our tracking was successfully executed and the result was quite good. Let's get to our next step. In our next step, we will be tracking the trajectory of the player. So what is tracking the trajectory? Here, trajectory means the previous path the player has followed. So it will give us a general idea on which path the player is running. So to do this, we just have to create a dictionary. In that dictionary, we have to create the value as a list which will store the central points of each bounding boxes of the player we are tracking. This will help us to remember the previous part the player was on. So to do this, we just have to improvise our previous function just by adding a trajectory, and then every time we detect, we will append the and that central point for that particular player ID to the trajectory dictionary, and then we will just display it on a screen. So yeah, here, let's run this. As you see, our trajectory tracking was quite successful and it will perform great in every scenario. So let's get to our next step. In our next step, we have to generate the heat map of the player on the ground. This heat map helps us find the key zone on the ground where the most important parts of match has been played. So to do this, we just have to create a dictionary for each classes and store their location throughout the video on that value with their class ID. So we just have to improvise our previous step, and then there is our dictionary, and then the key ID, key is our player ID, and this is the bounding boxes I have to save. So and increase that by 1. So let's run this code. Our heat map will look something like this, which tell us about the key zones like this, and these are the uh, key zones on the ground where most of the players were there throughout the game. So with this, you have learned how you can uh, track player and also generate heat map.
For more computer vision or machine learning related tasks, you can check our GitHub, where you will find everything in one place.